Well, you're definitely in the right place then.
Yay! All right, come on in.
There we go. Well, welcome. I get to be in that enviable spot after lunch and end of vendor meeting. So I'm Bob Fox. I'm an SE manager for Splunk. So quick show of hands. Who has not heard of Splunk? All right, those who've heard, who's actually used it? Who's got it running somewhere? Nice. All right, so my goal here is not to completely bore the people who know about it, but give enough information that maybe you can find out a little bit about the company, a little bit about what it is we do, where we position ourselves. I'm definitely going to jump into a demo, and I'm going to show the product here. And certainly we are out there. You can't miss us. Big black table in the front with all the T-shirts on top. So stop by and chat with us. We'll gladly talk about your specific use cases, or if there are any questions at the end of this, I'll happily answer them either here or there. So a little bit about Splunk quickly, and I'm not going to go into the full marketing type of presentation here, but the company itself was founded about 5.5 years ago. We've been selling the product for a little over 2.5 years right now. The people who founded the company managed large data centers and are very much IT people from their origins. They recognized a simple problem out there, and the problem was that when something goes wrong, I turn around, I take my best and brightest people, I stick them in a conference room or at a table, and everybody sits there and tries to figure out what happened. They're familiar with the world where level 1 people escalate things up to level 2 and 3 people sort of at the drop of a hat. I just don't have the tools to figure this out. I don't know. I don't want to do it, and I'll push it up. Everything is an escalation. They figured that there's probably a better way to go about dealing with this and sort of fixing those problems. Really, that's where Splunk came around. So if you look at 2008, actually the IT management tool space it took a whole lot of cash, right? So $100 billion was spent last year on IT management. Nobody will argue that IT and phenomenal IT systems are a business changer, right? Are an absolute paradigm changer for businesses. We need them. This is how we get things done these days. The problem with the IT management spend is a lot of it gets stuck into silos, right? And again, this is something else that nobody argues with. Certain silos. My networking team buys some tools, buys some hardware. My applications teams, my developers, all of those guys, everybody has little bits of tools. And the real problem with all of this is how do I jump from silo to silo, right? How does a level 1 who's diagnosing a level 1 customer support engineer who is diagnosing why somebody can't log in, if that diagnosis leads them to a networking issue or a database issue, do they have access to those tools? Do they have access to that data? Are they allowed to go and log on to production systems? This is the kind of stuff we're concerned with. And by and large, sort of a bold statement, but we really believe that this whole paradigm we have today of IT management is broken. And it's for exactly those reasons that I mentioned before, getting the data from silo to silo. Issues or problems that your problems are taking days and many hours to solve that could be solved sometime quickly. So the Splunk approach, and this is sort of what our founders came up with, and what we've been talking about, is this idea of a universal IT data engine. And the first thing I'm going to say here is this spans disciplines, right? So this is something that today and we'll talk about all this. This is something that security professionals are using today. That people who are responsible for applications or even pulling data out of silly things like web logs and tracing trades as they move through a system or anything that's transactional. This is something that's actually playing across the board. So what's this idea of universal IT data? The thought in the company is, well, hey, if Google was able to let me search over billions of web pages, why not take that? Why not take something similar and bring it into the data center? There's a couple of big differences between what Google does and really what Splunk does. If I look at IT data, I'll turn that around. Let's look back at Google data. How many types of data does Google actually index? 10, 20? Let's say it's 50 types. Look at the data that's in your data center, the data that you look at every day. We're looking at hundreds or thousands of different types of data coming from different applications that could be in different formats. Some of them that have customized log formats. How do I get all of that together and give somebody the ability to make sense of it? And that's really where Splunk comes in. The typical Splunk cycle looks like this, and it all starts up at the indexing on top. You'll hear me talk a little bit more about the universal indexing and how we get the data in there. But that's step one, right? Step one is get that data in. The beautiful thing about Splunk is we index anything. Don't care what the format is. If it looks like text or can be turned into text, Splunk will index it. Okay, this is one of the big differences out there. If you take the paradigm of a database, right? I've got columns. I've got data. I take the data, I break it up, I stick it into columns. Well, hey, that's my relational database, and that sort of works. Splunk flips that on its end. All right, Splunk says, let's index everything first. And then if I need something that looks like a column, if I need to have a specific knowledge about an element that's in those events, I'll add that later. I'll actually add that at search time, so it's completely dynamic. So again, I don't care what the file format looks like. I don't care if it changes over time. Index everything first. Once we've got that indexed, give me the ability to search through it quickly, easily. You're going to see some of this in the demo, and I'll actually run through a couple of search scenarios and show you actually how powerful the Splunk search language is. If I can search on that, I want to be able to do. I want to be able to add value. I want to be able to add additional information into that. What we talk about, and typically you'll hear me talk about knowledge sharing. Right? I may know everything about my specific application, the specific application that I'm in charge of running for my enterprise. I want to share that information. I want to make it so that information is understood by those level 1 people so they can stop bugging me in the middle of the night. I want to stop the escalations. I want people to be self-functional. I want to be able to go through and say, all right, you want to know everything that's happening on the development servers. I want to give you tools to easily figure that out for yourself, to share that with my colleagues, with my coworkers, and I want you to do the same. Right? Because I don't necessarily need to understand what an Oracle audit log looks like. But if you can show me out of an audit log what's a valid login attempt, what's an invalid login attempt, when was somebody accessing my database without going through an API, they were doing something directly at the command prompt. That's stuff that I'd like you to tell me about, so I can factor that into my security profiles. I can report that up to my auditors if need be. Monitor and alerting, and we'll talk about a little bit about this, but hey, I've got these searches. These searches can do somewhat interesting things. You're going to see some searches based on failures, on things that are going wrong. Well, I can automate them, and I can have Splunk alert me when specific things happen. If I'm looking for a certain number of events or a certain pattern, we can do that. We can look at that. We can alert that back to you. I want to report on these things over time. right? So, give me a historical perspective. Maybe I'm looking at CPU utilization. Maybe I'm looking at a memory footprint. Maybe I'm looking at SSH login attempts that are coming from a specific IP address over the last year. Let me grab all that data. Let me sort of make sense. Let me report that back. Let me show my boss. Let me make some pretty pictures and show my boss and show the auditors and anybody else who might be interested in seeing something from that data. Give me the tools to go through and review these logs. That is a whole nother aspect, a whole nother issue here. When we start talking about compliance and we talk about, is somebody actually reviewing my logs? Tell you what, if my application is generating 100 gig of logs a day, that's a lot of data to go through. Is somebody actually going to sit there and read every line? Well, maybe not, but let's make it easy. Let's give me a framework to go through and actually analyze the data that's there and take action on those events that I've deemed critical, and show me those events that I've never seen before. So that's the whole review cycle. On the right-hand side of the slide, you see a bunch of application areas where we play. The one up there on the top is that whole idea of application management, and truthfully, that's where Splunk started. And I want to say it's probably a little over half of my customers today start with this whole idea of application management. Something broke. I threw an exception, I threw an error, the network connectivity went away. Something happened that stopped somebody or something from doing work. I want to get to the bottom of that. I want to figure out what that was quickly. Sort of on the other end of that, the bulk of the customers after that are dealing with security data, and it's 4 or 5 down on that list. If I start looking at my IDSs and my routers and my firewalls and everything else that's out there generating a ton of data, if I want to do something like, or for instance, track a user from the time that they got into my multi-tier website, to the time they posted an entry over in the database, am I able to do that? How easy is that? If I want to start looking at sort of bigger picture things, what files were touched? When was the last time that the Etsy directory or some file in that Etsy directory that holds all my configuration data was changed? And does that happen to correspond with when that application stopped working? It's that type of those types of issues. Now, looking at where customers are using it today, I talked quickly about that whole application management space. Vodafone's a customer and have very much reduced their escalations. A 90% reduction in escalations is sort of cool, especially if you're the one on the other end of that phone that rings. On the sort of the compliance space, and this is very much tied to security, but another place where a lot of people and more people are using Splunk. Galacoral is Galacoral is actually how they pronounce it, is a betting service over in the UK. And they do a lot of these little tiny wagers, and where it's all legal, and everything's done on credit card. Okay, so if I lose, the charge comes off my credit card. If I win, there's a credit that comes back to my credit card. Obviously, huge PCI huge need for PCI compliance, right? They report everything back to Visa and MasterCard, and they want to know they're instructed with coming up with, hey, is your security in place? Is the credit card data safe? Are the customers or my customers, MasterCard and Visa, is their data safe? So Gal is using us to actually generate all of their PCI reports. One of the options that we have to Splunk is we have a PCI module that goes and basically comes up with a whole bunch of those PCI reports that the auditors are going to look for. On the security side, we're not moving forward. There we go. I wanted to talk a little bit about Motorola. So Motorola, for their supply chain, global supply chain, their security folks are using Splunk really at every step of the at every step of the way. They're dealing with incident response, they're dealing with analysis, and again, going through all that data that I mentioned before. So I think I mentioned before that we've been actually selling this product for about 2.5 years, coming up on 3 years. And in that time, a couple of really exciting things have happened. We've got 900 customers right now, and I'm talking about paying real usage customers. Customers who have integrated us or are in the process of integrating us into their business and into their daily life. The other exciting number for me up here is just 300,000 downloads. You can download Splunk today. As a free download, you can actually use Splunk for up to 500 meg of data a day. You grab that right from the website. The people who've done these 300,000, well, certainly there are people who are looking, there are people who are evaluating. But something interesting that's happened there is these are also people who like to build things and like to sort of expand products. They are phenomenal for sharing with us new features that we want to, or that they would like to see added in. Or hey, here's a great way to use Splunk with fill in the blank, MySQL, DB2. Pick a product, Cisco picks, right? So here's the ability, and through something we call Splunk Base, here's the ability to go and download what we call Splunk applications, right? So I can download today. I can go out to Splunk Web and grab Cisco for Splunk for Cisco picks, and that'll give me a bunch of reports and a bunch of access methods to get that data from my picks firewalls. There's Splunk for network security. I mentioned before MySQL. There's a bunch of applications out there. Again, you know what? If you choose not to use the applications, great, right? But take a look at them. You take a look at the searches people have put together. Splunk for F5 is actually something that just popped out there. That was actually written in concert with the folks at F5. A lot of good, a lot of goods come from that. Here's Splunk's sort of secret sauce, right? Here's really what makes it cool. I mentioned before I can download it today. Assuming you've got a decent connection, it's going to download in a couple minutes. I can install it on Linux, Windows, any of the operating systems you see up there. I can install it in about 10 minutes. Give me about an hour to start pulling some data in there, and you've got something useful, and you've got something that you can actually use and get value out of today. It's a very short sell, and I invite you all to do it. Go download it. Download it while you're here, and let me know. And if you have any questions, we're sitting at the table up front. I promised I'd talk a little bit more about the universal indexing, and really this very quickly leads into a discussion of how do I get data into Splunk. Splunk, hopefully not too much of a surprise. If I see something in a file, if I can see it off of a shared file or it's local to Splunk, I can read it. I'll read through it, I'll bring it in. I don't care if it's compressed or not. I don't care if it rolls or if it's tied into any of your archival methods. We'll get that data in if it's a file. I can also listen to network ports, right? UDP, TCP, SSL. It takes me, I believe, it's either 2 or 3 clicks to turn a Splunk server into a syslog host. I open up a listener on UDP 514 and point my syslog generating devices to the log host, to that Splunk server, and that data is just going to come in. A very easy way to start getting data in. We've got this input method called a scripted input. This is actually fairly powerful, and super easy to work with. The question is how do I get data, out of a database? How do I get data out of a Cisco picks firewall or something that's running, OPSEC or is going to require a challenge for me to get data from? Now, really what it turns into is if I can write a script to get that data and pull data in, I can get it into Splunk. I mentioned before database audit logs. This is a wonderful use case for scripted inputs. If I want to see, my personal familiarity is with Oracle's fine-grained audit logs. You've got two choices. You can actually have them hidden in the database, or you can write them out to a text file. Text file is not a problem. Written into the database, I have to write a query to. Now, I suppose I could go to my DBA and say, hey, can you run this report, which is going to show me if you're messing around in the database? Or we can have Splunk do it. And now I need to have that report written once, and it can comply with all of my company security policies about getting to that database. But have Splunk run it. Have Splunk run it on a schedule and sort of eat that information that way. One of the other ways we get data into Splunk is what we call a Splunk lightweight forwarder. So I mentioned before that whole idea of syslog and getting data in over UDP 514. That's wonderful for data that's syslog friendly. Right? But what if I'm talking about data that's got a bunch of XML in it, or J2EE logs, or something that's multiple line? In that case, I'm probably going to look at, again, what we call a Splunk lightweight forwarder. And we call it lightweight because it's got two very important controls to it. I can actually control how much of the CPU it'll eat at any time. I can control how much of the network bandwidth it'll use at any time. So a Splunk lightweight forwarder is going to sit out on an application server. Its job in life: watch files that move, whatever I tell it to watch. Watch those files and send it back to Splunk. Send it back to the Splunk indexer. Hopefully you would expect and challenge me on the fact that there's a whole bunch of security wrapped around that, as to what can be done, as to how they can be configured, and I'll gladly discuss any of that with you. So back to this whole idea of universal indexing. Okay, we grab data. We look for a timestamp in the data. Okay, that timestamp, time in general, is our primary key. It's what we're really interested in. It's what we index by. Out of the box, we have about 30, 35 different timestamps that we recommend. And yeah, they're in a certain order, not that we recommend, that we recognize. And they're in a certain order. And maybe I need to modify that a little bit to deal with something specific. But it's all customizable. It's all changeable. I like to say if the developers start writing and putting their timestamps in Klingon, we can probably come up with a way to parse that out of the event and turn it into something everybody else can read. Epoch, not a problem. British European date formats, definitely not a problem. We're going to pull that in. Again, there's no specific adapters here. We're not talking about coming up with any Java code that's going to collect anything. I don't care if Oracle goes and changes their log formats between version 11 and version 12. It's of no consequence to me. Bring everything in. If my application designers, my developers start changing the way that our logs look, again, I don't care. Let's bring it all in. We use the file system as our data store, right? So no DBA required. Okay, we're going to drop everything to the file system. What we end up doing is putting a compressed copy of all the data we see. Also, our indexes are out there. We can compress that all fairly small. The nice thing about putting everything on the file system, number one, it's fast. I mentioned the no DBA required, right? Also, it's easy to back up. It's easy to manage. Splunk will self-manage any of the data. So once we start talking about retention policies or only keeping a certain amount in size of data around, Splunk will manage all that. The data itself is all signed, right? And we sign data at a couple of different points in its life cycle. Right? I'll sign data as it's coming off of that Splunk lightweight forwarder. I'll sign it as I write it into the index. I'll also sign it as I go and stick it off onto an archive. Right? It's very trivial for me to go through and find where data was mucked with at any one of those points. Scalability is something that we talk about as well. Splunk scales pretty linearly as I throw resources onto it. Okay, and we're software, right? We're not an appliance. I throw more CPU, more memory at it. Splunk is going to scale with that. Splunk can scale outside of the box, though. So I can come up with multiple Splunk instances, either running on the same server or running across servers or running across data centers, across time zones. I can have regionalized or local Splunk instances wherever I want. We've got the ability to now search over all of those instances, something that's called distributed search. I log into one server, I pose my search, my query to one Splunk server. It federates that search to everything else that I've got the ability to see. So if I want to come up with a rack made up of nothing more than Splunk servers, I can do that. If I want to have a server here and a server in London, two different Splunk instances, and I want to search across them, that's doable. And hey, here's a bonus. We'll even take care of all the timestamps for you. Right? So I don't care where the data was generated or where it originated. When you're looking at it, you're actually looking at it in an Eastern time zone, or wherever the time zone is that you happen to be sitting in, your primary Splunk server happens to be sitting. Searches are key, right? Search, everything in Splunk is a search, and that's really what we're all about. The goal with Splunk, and you'll see this as part of the demo, is let's keep that search as easy as possible. I hate to say it, let's keep it as easy as Google. Right? I want anybody to be able to use that. Now, on top of that, I want to give you the tools to expand that search, to expand the search commands, to make some, to do some really nifty things with the language. But let's keep it simple. I'm going to go a little bit faster here, and just so I can get to I can get to the demo. Splunk alerts, you'll see some of these too. These are based off of searches. The way alerts work within Splunk is I can trigger something, and I'll get to the something, but I can trigger based on the number of occurrences of something raising or dropping in a percentage, and it's always over time. Right? So I'm going to look at the number of invalid login attempts over the last 5 minutes. Okay? If that's over a certain threshold, I want Splunk to throw an alert. What are the alerts? Well, hey, it can send you an email, and sure, you can customize that email to make it look like whatever you want. We can write out to an RSS feed, okay, built into the product. We can run a script. Again, sort of the catch-all here. Now I can take a Splunk alert script, I can fire that off, and I can have that script open a help desk ticket, send a monitor event to Nagios or OpenView. I can have it, run an additional search. So we sort of what I'm showing you here is Splunk, and what I will be showing you is Splunk through the GUI, something we call Splunk Web. But I can access Splunk through the command line. So I can have that search script go and run another Splunk search and correlate some values or bring some other information back. Reporting is that whole science behind pretty pictures, right? Let's make things so that it's visually interesting for me, for my boss, for anybody else who's interested in looking at pretty pictures. What you'll find with Splunk is it's fairly simple to come up with ad hoc reports and add in a whole bunch of other statistical information and run some other cool commands. The whole idea of sharing is what I was talking about before. If I am a subject matter expert in a particular portion of the data that's coming in, allow me to share that. Allow me to tag the data. Think Flickr or anything that's out there. Allow me to start making sense of host names, right? So I can start tagging hosts as production database. And then if I wanted to do a search across all database servers, I could do that. If I wanted to do a search across all of my development servers, I can do that. Allow me to do the same thing with the events. One of the things that we can do is something called an event type. And I can set an event type to be a login event. Okay, and so, all right, here's a login event. Here's how here's where somebody logged into MySQL. Here's where somebody logged in through an SSH port. I want to search for all login events for a specific username or for a specific source IP. That's something we can do. Again, let's start adding knowledge. Let's start adding tags to this data and sharing it with other people so that the data makes sense. What you end up doing in sense, and you could, is come up with a standardized dictionary, of these tags. All the ones I mentioned before. Login event, production. I want to see all of the login events on production that resulted in a failure. And I don't care where the source is coming from. I don't care where the data is coming from. I've got the ability in Splunk to set up dashboards too. Dashboards are dynamic. I can take those reports, drop them on a dashboard. Some of the ways that people are using us today in the security realm. Too many out here to sort of list, but absolutely proxy logs and router logs, configuration files, who changed what. Physical security. I've actually got a customer of mine in New York who's got Splunk wired into their card access, their perimeter access system. Yeah, so not only now can they tell me where you logged in, they can show me where you badged in as well. All of that data can come in. Using Splunk now to as a receptor for alerts that are coming off of my SIMs or coming from any of my other monitoring feeds. Bringing all that into a common framework that's searchable, that's reportable. Well, that might make sense. I've got customers who are actually taking in help desk tickets. I will Splunk the help desk tickets and have them now as a matter of record. Right? So if I am looking at things over time, I can see, okay, well, here's where somebody changed an entry in Etsy password, and here it was an hour and a half later that the help desk ticket on that system came in. All in one screen, one view, without having to log into different systems, without having to sort of manage or navigate our own corporate mazes. I'm going to pop on a bunch of that on the demo. I sort of want to get into that. So any questions real quick as I jump over to this demo? Good. So a couple things here. So I've got a Splunk instance running. I mentioned before we try to keep the search engine interface, the search interface fairly simple. I'm going to go and I'm going to do a quick search, and this is just going to be a text search. And I'm going to search for SSHD. Well, not super exciting, and also not super. What's the other word I was looking for? It's getting towards the end of the day. So not super interesting, but hey, here's just a quick search on a text string, and it pulled up everything that had the term SSHD in it. Okay, I would expect that it pulled out all of my syslog entries that were tied to SSH, to the SSH daemon. Well, wonderful. I'm looking at some of this data here, and I purposely got it pretty sparse, but hey, let's we can scroll down in here. Failed password, right? So that's sort of interesting. Well, I can click on this term failed here. And you see that that adds it right up to my search. I can click on that password as well. And again, we're doing pretty simple searches here. I'm just using the core search language to go through. The data down here, very much the events. I haven't messed with these events. These have actually come in. Well, here's where Splunk starts adding value. Number one is I can show this timeline. Okay, the timeline lets me see very quickly, very visually, where these events are coming in. Keep in mind my search, because this is all tied directly to that. Okay, I am looking here for every event that has the term failed password in over all time, and looking at the histogram here, it's where that data came in. Well, the 21st seems fairly interesting to me. All right, so I can click right on that histogram. What I've done is I've just changed my search. Now I'm only looking at those events that happened on the 21st. Fairly simple. I can zoom in on that, and now get a better feel over time. And the resolution is not exactly where I'd like it to be on this projector, but it's all good. where now I'm looking at that over time. I want to grab a range of time, I can highlight and bring that in. So again, keep in mind what I'm not doing here. I'm not logging into any system. I'm not gun zipping any files. I'm not running Perl scripts or anything else. And I can be looking at multiple systems here. And I'm getting that data in fairly quickly. I'm going to go back and sort of clear my time constrictions. Go back to that failed password search. I'm going to make that timeline go away so I have a little bit more real estate up on the screen. You'll notice that I've got this line here called fields. Okay, I mentioned before how we sort of do things backwards. We index everything first and then assign those column names or assign those field names later. This is what I'm talking about. I'm talking about these fields. You know, if I want to look, so we've got this field called username, and we've extracted the usernames right out of this data. You know, I can do a little click on that little arrow next to it and see that distribution of usernames. Something that's probably more interesting to me is the source IPs. Where's this data coming from? Who is actually causing invalid login attempts? Where are these attempts coming from? You see, I've got something here called report on this field. I click on that, and I jump into Splunk's report writer, Splunk's report generator. Okay. Very quick, very quick visual representation now of where those IP addresses are coming from. If I scroll down a little bit, I've got the table. You know, I've got all my percentages. This graph itself here, I can do a couple things now. I can save that search, and I can save the search I did. You know, we'll do a save search here. Let's just call it invalid password. It'd be better if my browser didn't just freak out on me. Okay. So I can save that, and I can add that to a dashboard. I can have that search run on a schedule. Say, hey, send me a link that generates that report once a day so I can see it without thinking about it. Have that sent to me in email. If I were to click on one of these pie slices in this graph, and this is all interactive, I click on that, what you'll notice here is my search has changed. Right, so now that specific IP address is in my search. Again, it's sort of point and shoot, right? Just start clicking. I've got this option here to show fields. I'm going to expose that as well. Okay, show fields now lets me take a look at that metadata, that field data that I've extracted, but in context of the individual event. You know, so I want to go and here's the event. You know, here's that IP address. You'll notice there's another little pull down next to that IP address. This is something we call a field action. A field action allows me to tie any element from any event and hand it off, tie isn't the right word, grab that and hand it off to a URI. You know, in this case, I want to do a geolocate on that particular IP address. I can tie that in. I could actually go a little bit further into this, and I could write a Splunk command. Okay, Splunk commands, fairly simple scripts in Perl, Python, or really whatever else you want to write in, that will go and analyze this data or allow me to work on this data as I go through. You know, I want to go and I want to write a script that does some data enrichment and actually puts that data, puts the source country or really whatever I want it to come up with right here in the event. I could do that. Not in the event itself, but in that metadata. We don't actually touch the event. We'll never change that event. I wanted to take this, you know, one step further. Let's go and let's lose that IP address. And for whatever reason, my keyboard is not working. This is way cool. Okay, so we're going to do this way. We're going to do it the old-fashioned way. We're going to go old school. So I've got to have something that's stopping me from typing, so I'm sorry. All right. will work without that. So I've got that search now of invalid login attempts, and fairly easy to come up with. But one of the things I can do with Splunk, I mentioned before that the search itself, the search language, can get fairly complex. I can take that search and I can say, okay, well, here's all of my invalid login attempts for the last day. Here's the IPs, here's the usernames. What I can do is take that and run that in what we call a sub-search. So just kick back to me a list of IP addresses that we've got this invalid login attempts, that we're getting invalid login attempts from. Take that list and cross-reference that with every place where I've got a valid login or an accepted login. Okay, you sort of run those two together and it's going to show you, well, hey, every place where somebody's logged in after X number of invalid login attempts someplace else. Very simple search to come up with in Splunk. I even show you if my keyboard is working. So we saw some reports. Those reports I mentioned before could be dropped into a dashboard. If I come back here, I had set up just before a dashboard that I call security. Here's my failed password report, and my failed password report shows me a discrete number of failed passwords over time. Here's the IP, failed password by IP report that I created before. That's the reports. I mentioned before, any of these can also be turned into alerts. I want to know if I get more than 5 invalid logins in that time. Send me an email. Make a red light go off someplace. That is the bulk. That's the sort of the quick intro to Splunk. I mentioned before, I'm going to be here. I'll be here all week, try the veal and all that fun stuff. But let me know if you have any questions on that. If you want to go into a specific use case, I'll be here. Also, Rob Ide is manning the booth with me as well. For now, any additional questions? Anything I can answer on Splunk at this point?
The search query you run is on all your data. Can you exclude some data sources as well? Okay,
I'm sorry. Can I which?
Can you exclude data sources?
I can. Right. So I'm running and this would be this is something I'll gladly show you out at the booth when the screen's working. But I've got full logic in these searches. So yeah, but it's the click part that's the problem right now. So I could, from what I was doing, you can actually alt-click and that'll add a not, ands or nots, parentheses. All that's part of the search language. So I can say I want to see everything that's not in development. Just show me router configuration files, but only from Europe and that are tagged Cisco. Yeah, but absolutely, we can drill down that way.
Question.
Yeah.
The slide you had previously showed NetFlow as a potential source to input into Splunk.
Yep.
What is also if you try switching your Finder, it might work to keep them running with Firefox 7. This is my Mac sometimes. Just wondering what are some of the use cases for that? What can be done with that data? What versions of NetFlow can Splunk take NetFlow in directly, or does it have to be put through a tool like SQLD or something like that to change that into a text format?
Yeah. So we need to have the file in a text format, right? So it's got to get text in there. The typical use case, and Raphael, correct me if I'm wrong here. The typical use case around NetFlow data, is not that I am constantly pulling that into Splunk. It's hey, something's going wrong. There's something I'm trying to isolate. Something I'm trying to get to the bottom of. I'm going to turn it on. I'm going to run NetFlow for X amount of time and look through the data. Now, we do have customers who are just pumping all of their NetFlow stuff through Splunk. It's your tax dollars at work. But it's sort of a bigger thing. You look like you're jumping.
Looking for ways to visualize NetFlow data over time.
No way. Visualization is not a good idea. I'm just kidding. So I have an app for Argus. I play with Argus a lot. I've actually posted that maybe this week. So I basically thing is, if you do more of, you could do, if you're really smart, you can kind of mimic what the NBATs are doing, right? You do some anomaly detection on it. Splunk gives you all the mathematical or powers to do the analysis. There's all kinds of operators in it. You can do standard deviations of things, and you just have to stitch the commands together the right way so that it does the analysis for you. I don't know how Arbor does their anomaly detection on the data. They probably have some algorithms in the back that they use to look at certain stuff. But if you know how it's done, you can use this as a data store, and then build on top of that, you can build your analysis infrastructure.
Right, you have to normalize what's typical flow. And
Absolutely.
It's really complicated. I'm more like I do simple charts with RD tool.
Yeah.
Something that could index the data for a little bit longer term. Go back and see, okay, this is my primary type of traffic.
You can do exactly the same thing that RID does. I'm not sure. Are you familiar with summary indexing?
In Splunk.
Yeah. So one of the issues is that NetFlow is a huge amount of data, right? So you index all this stuff. If you have to do reporting on the last 30 days, if you want to generate your RRD-like graphs, you have to touch all these 30 days of data. Now what RRD does is basically says, well, I'm just keeping aggregate numbers. So I'm going to collect, or I'm going to remember how many times I've seen this IP for this one day, and then over every day it keeps these aggregate statistics. You can do exactly the same thing with Splunk, where you say, on a daily basis, I run all my statistics, and I'm running, or I'm saving all these aggregate data in different index, basically. So I'm just storing now, today, this source IP address this many times, this IP this many times, these, whatever we want to collect. And then when you do your reporting, you go over that index, which is very quick to address because it's not much data in it. So you could mimic all of your RD-like reports in Splunk by doing this. And then if you have any other heuristics you want to run, you want to say, hey, I want to, I don't know, look for machines that are talking to more than n machines, or you kind of encode certain policies to say, I'm going to start tagging machines and say, all these are my web servers, and if I ever see my web servers talking on ports not 80, then I'm going to alert. Or if I ever see any machine looking or being addressed on more than 6 ports, something is wrong, because I should not have any production server or any machine for that matter that communicates on more than 6 services. Right? It's something wrong. Either it's a development machine or something is probably not right. So you can, I think if you start thinking about these use cases, you can come up with a whole lot of very simple things that you can implement and run on an hourly schedule, on a daily schedule, do these kind of monitoring things.
The connector, say if I'm running flow tools or something like that to get that into a rotating text file.
Yeah.
Can you, does that need to be running on the same machine that the Splunk reporters is running, or can you use one of the connector interfaces?
You can use either a forwarder, and that runs the NetFlow listener and writes to a file, and then you can basically index that file in the forwarder, or on the indexing machine. What I'm doing with Argus, I'm basically dumping the files into spool directory. So that in the Splunk install in bar spool Splunk, every file you drop in there is indexed and then deleted. So it's a sinkhole. So I'm just dropping a file in there with my data so that it's being deleted, because I don't like FIFOs. In general, you could use a FIFO, but they're really unreliable. Because if you write too fast and just drops events, you'll never know. So that's why I'm using a file as an intermediate kind of store. But I don't want to keep the file around because I have it indexed afterwards. So I'm just dropping it into the sinkhole with indexing. I can share that thing with you if you're interested.
Yeah, later we can talk about that. So you wouldn't recommend actually piping output to another process, so you don't actually write it to disk?
Not through a FIFO. If you can directly get it into the process.
Like, will the Splunk forwarder listen on standard in?
The forwarder is really the same as the indexer, so you still set up inputs to read from files, FIFOs, or whatever. So it's not a binary that you can pipe data into. So you still have to set up an input somewhere. I mean, what is your recommended way of doing this?
So what we typically want to avoid is any kind of blocking, right? I don't want to. I want to avoid blocking. I want to avoid any type of interruption of the data network, service hiccups, whatever. The Splunk folder is network aware, right? So it's state aware. It knows what it's sent to a Splunk indexer. The Splunk indexer knows what it's received. If there was a network connectivity issue, if there was anything that stopped data from getting there, CPU got hosed, bottlenecks, or whatever. Rather than dropping data, which is something we'd see with UDP, which is something we'd see with TCP if it wasn't buffered correctly, which is definitely something you'd see with a name pipe. Using the Splunk forwarder, it survives that. So looking at a file that's been written and letting Splunk do what Splunk does with that is probably the safest way. We mentioned, or Rafi mentioned the whole idea of a sync call. We don't have to keep that data around. We'll actually self-manage that. You drop it in a Splunk-defined sync hole. We'll process it. When we're done processing it, we unceremoniously make it go away.
So the forwarder doesn't really care about a particular file handle. So say if the file goes away, gets recreated, and goes to a different inode or whatever, it's intelligent enough to follow that?
It is. So what we do is we're not so much concerned with file names. It's part of the equation. It's not the full equation. So typically what we're doing when we see files is generating checksums. Show me a checksum at the beginning. Show me a checksum at the end. All customizable. For those people who have huge amounts of headers that are all the same. Incredibly customizable. But factor that in as well. So if I do roll the file, I rename it, I gzip it midstream. We survive all of those things. Any more questions? No, we're exactly at the 45-minute mark, which is sort of cool. Make sure you grab a T-shirt from the ugly guy who's sitting out at the Splunk booth. Like I said, I'm here if there's any questions or you want to see anything work differently. Thank you. Thanks for your time.